So for what feels like forever, one single architecture has been the undisputed king behind almost every AI we use, the transformer. But you know how it is, a new challenger has stepped into the ring. This one's called Mamba, and it's promising to be faster, way more efficient, and maybe, just maybe, a little bit smarter. Let's dig in and see if Mamba really is the new brain that AI has been waiting for.
You ever have this happen? You're talking to a chatbot, maybe you've given it a huge document to read, and all of a sudden it just slows down. Or worse, it completely forgets what you were talking about just a few minutes ago. It's super frustrating, right? Well, that feeling points to a really deep, fundamental limit in how most AI models actually think today.
And to get why that happens, we've got to look at the current champ, the transformer. For all its amazing power, it has a core design flaw, and it's a big one. As you feed it more information, it doesn't just get a little slower, it gets exponentially slower. And this right here, this is the heart of the problem. If you just double the amount of text you give a transformer, you don't double the work it has to do. Oh no, you quadruple it. And that approach, it just doesn't scale. Not when we want AI to handle entire books or massive code bases or super complex reports. So this whole issue has a name. It's called the quadratic bottleneck, and it's the technical reason for all that frustrating lag. The model literally gets bogged down by its own thinking process, creating this invisible wall that just caps how much it can handle at once.
Okay, but why does this happen? Well, a transformer's magic trick is something called self-attention. To understand the context, it scans the entire text at the same time, comparing every single word to every other word. It's incredibly powerful for understanding relationships in text, but you can see how it also creates this gigantic, quadratic workload.
And this, my friends, is where Mamba comes into the picture. It was introduced in late 2023 by some brilliant researchers at Carnegie Mellon and Princeton. And it's not just a small tweak. It's a completely different way of thinking about the problem.
See, Mamba is built on what's called a state space model, or SSM for short. The best way to get it is to imagine you're in a maze. Instead of stopping at every single turn to reread the entire map from the beginning, you just keep a running summary in your head of where you've been. It's way more efficient, right? You're just focused on what's next.
The difference in approach is just fundamental. A transformer tries to absorb the whole page at once. Mamba, on the other hand, acts a lot more like you or me. It reads sequentially, word by word, and as it goes, it's constantly updating this compressed summary in its memory of what's important. So how does it decide what's important enough to keep in that summary? Aha! Well, this is Mamba's secret weapon, selectivity. Its rules aren't fixed, they're dynamic. Mamba literally changes its focus depending on the words it's seeing, deciding on the fly what to remember and what to ignore. It's like having a built-in filter for all the noise.
And when you look at the results, wow, they're dramatic. Mamba's workload scales linearly, which means it stays fast, even when you throw massive amounts of text at it. We're talking inference speeds up to 5 times faster, way less memory usage, and it just breezes through long documents that would make a transformer completely choke.
Okay, but this all sounds a little too good to be true, doesn't it? And yeah, it kind of is. Like any big engineering decision, Mamba's incredible speed comes with a pretty significant trade-off. This quote really just gets right to the heart of the matter. The very act of making that efficient, compressed summary of the past is, well, it's lossy by definition. I mean, you can't squeeze a whole novel down into a single paragraph and expect to keep every single little detail, right?
So what this means in the real world is that Mamba might forget a very specific detail from page 1 of a document because its selection mechanism decided it wasn't critical at that moment. And once that little piece of information is gone from its compressed memory, it's gone for good. That makes it not so great for tasks that need perfect word-for-word recall.
So here's the fundamental choice we're looking at. You have the transformer, which keeps absolutely everything in memory for perfect recall, but it pays a huge price in computation. Then you have Mamba, which goes for efficient compression. It's fast, it's light, but it does so at the risk of forgetting some of those finer details.
So if one model is slow but remembers everything, and the other is lightning fast but a bit forgetful,
What's the solution? Well, the industry is already figuring out a really elegant answer. Why choose? Let's just combine them.
And I want to be clear, this isn't just some theory being kicked around in a research lab. The biggest names in AI, we're talking NVIDIA, IBM, Microsoft, they are all in, already building these hybrid models. They're literally creating a new kind of AI brain by mashing together the best parts of each architecture.
The strategy is just so simple and so smart. You let the transformer layers do what they do best. Obsess over the tiny, fine-grained details with that perfect recall. And then you let the Mamba layers do their thing, efficiently grasping the long-range context, the big picture of the entire story.
And this is a fantastic real-world example of that. For a super complex job like 3D semantic segmentation, which is basically telling a computer what every single point in this 3D scan is, you absolutely need both. You need the transformer's eagle eye to identify the leg of a chair, but you also need Mamba's efficient, global understanding to know that the chair is part of a larger living room scene.
And the numbers totally back this up. Look, a transformer-only model gets a score of 77.1. A Mamba-only model gets 76.9. Pretty close. But the hybrid model that combines them, it scores 77.8. It's not just an average, it's a true synergy where the whole thing is actually better than the sum of its parts.
So you see, the future isn't some big showdown, some cage match to see which architecture wins. It's about building a more flexible toolkit. It's about creating more sophisticated AI brains that can use the right tool for the right kind of thinking. And that leaves us with a pretty fascinating thought to chew on. AI is evolving from having a single type of mind to having a modular brain. So if it can start combining totally different ways of thinking to solve problems better and faster, what other impossible challenges are suddenly, finally within our reach?